Hello everyone, welcome to my channel. Today I will tell you about an application where thermoelectric modules can be used to produce electrical energy from heat. Transistors or switching components used in power electronics dissipate heat according to the current passing through them and need to be cooled with heat sinks. The choice of passive or active heat sinks is generally determined by the amount of heat dissipation. What's the idea? The idea is to generate electrical energy by heat dissipation of electronic components and use this energy for its own cooling. Generated electrical energy can be used to drive a fan to increase the cooling effect of the passive heatsink. So we can obtain a heatsink with increased cooling capacity without an additional power source for the fan. In my previous videos, I have shown you that thermoelectric generators can generate electrical energy from heat with an efficiency of around 2% at 100 degrees Celsius temperature difference. It's generally not desired for the surface temperature of electronic components to exceed 100 degree to 125 degrees Celsius. This temperature difference will be enough for us to produce the electrical energy needed for the fan of the heatsink with the thermoelectric module. Today, we will measure the surface temperature of a passive heatsink with 80 watts heat dissipation. Then, we will add a thermoelectric module and fan to the same heatsink and measure the surface temperature with 80 watts heat dissipation and compare them. The important thing here is that the existing heatsink will have the same surface and the same material weight. How will the experiment be done? The heatsink I used consists of a main part of 8 by 12 centimeters and additional part of 8 by 8 centimeters. Thermal paste was used on the contact surface of the main part and the additional part. 4 TIP 120 type transistors were used for heat dissipation and were made conductive with a resistor and will dissipate all the given electrical energy as heat. These transistors were mounted on the main part of the heatsink. In the first part of the experiment, both the transistor surface temperatures and the heatsink body temperature will be measured by testing with 80 watts heat dissipation. In the second part of the experiment, thermoelectric modules will be added between the main part and additional part surfaces of the heat sinks, and a fan will be added to the additional part of heatsink. In conclusion, an evaluation will be made for both situations. Now let's move on to our experiment. As can be seen from the table containing the measurement results, the transistor average temperature was 151 degrees Celsius, and with thermoelectric module and fan condition it became 99 degrees Celsius. The heatsink average temperature was 124 degrees Celsius, and with thermoelectric module and fan condition it became 77 degrees Celsius. As can be understood from the results, by using the same surface area and the same weight of metal in the heatsink manufacturing, the thermoelectric generator supported cooler can reduce the transistor surface temperature by at least 50 degrees Celsius. If we look at the benefits of the application, number one, although it's a small value, it can save the electrical energy to be consumed for the fan. Number two, there is no need for an additional fan supply and temperature control circuit on the main electronic circuit for the heatsink fan. Number three, in order to increase the performance of the existing passive heatsinks, this type of heatsink can be replaced without the need for an additional fan supply output. Number four, a lighter structure can be obtained by replacing electronic circuits with a lighter weight thermoelectric generator supported heatsink. I hope this experiment will be useful for your applications. I would be very happy to see your comments and suggestions. If you like this video, please subscribe to my channel and don't forget to leave a like. Thanks everyone. See you in other projects.